that we're looking at in proof is contrapositive statements. So if we know a statement P implies, so the arrow means implies, if P implies Q, then the contrapositive is just the opposite. So this dash just means the opposite. Okay? So what we do is we read backwards, but we put dashes above the letters. So not Q leads to not P is called the contrapositive. Okay? Not P implies not Q. Okay? So a dash above means the word not or opposite, and a contrapositive means you just change the order of the letters. Okay, so copy that and come across. Okay, if P implies Q, then not Q implies not P. If the first statement is true, then this must be true. Okay, if first statement's true, then the contrapositive must be true. That's all you need to understand this stage. If the first statement's true, then the contrapositive is true. And obviously, if the contrapositive is false, then this is false. Okay, they're either both true or they're both false, which I think is on the next slide. So copy that and come across. Yeah. So no, it's just an example. So if you go back to that again, they're either both true or they're both false. You can't have one of each. Okay, so they're either both true or they're both false. Okay, you can't have one true and one false. Okay, so let's have a look at some statements of contrapositive. If it is raining, then the road is wet. So that's P implies Q. So the contrapositive is you take this statement, the road is wet, and then you just put the word not. And then this is the first statement, it is raining, and then you just put the word not. Okay? So that's a contrapositive. Next example, if a triangle has two equal sides, then it's an isosceles. So we take this, so P implies Q. So we take this statement, if a triangle is not isosceles, and then we take the second statement, get that out of the way, triangle does not have two equal sides. Okay, so it's pretty straightforward, but it's just another skill you need to learn. Okay, copy that and come across. Okay, so this is where, how I said, so if the original statement is true, then the contrapositive is true. If the original statement is false, then the contrapositive is false. To prove a conditional, we look at the contrapositive. It's helpful to look at the contrapositive and see if it's false or true. If the contrapositive is false, then the original statement's false. If the contrapositive is true, then the original statement's true. So that's the important thing. Okay, so let's have a look. Hopefully, copy that down, come across. Okay, so I've written, this is straight out of the textbook. So let n be an element of whole numbers. Okay, so if n squared is even, then n is even. So again, we've talked about this before, you can't just give examples. Can't give specific examples. You can't say, oh, n is 2, n squared is 4, therefore true. That is not a proof. Okay. So the contrapositive is n is not even. So not even means it's an odd number. And the contrapositive of n squared is even, which is n squared is not even. That means that n is odd. So not even. So putting the word not even means it's odd. Okay? So in the previous ones we talked about just putting the word not, but a not even number is an odd number. So, excuse me. So if n is odd, then we define n as 2n plus 1, where m is some whole number. Okay? So when we square, because we want to square it, So n squared equals 2m plus 1 squared equals 4m squared plus 4m plus 1 equals 2 times something equals 2 times something, where k is equal to that number, and k is an element of whole numbers. And we've got that 1 left over, which means that n squared is odd. So therefore, the contrapositive, if n is odd, then n squared is odd. If n squared is odd, then n is odd. So the contrapositive is true. So therefore, the original statement is true. Okay? All right, so let's have a look at another example. Copy that and come across when you're ready. Okay, so again, I've just got this out of the book. Okay, if that leads to that, so write down the contrapositive. So again, not being an odd is being an even, okay? And not being even is being odd, okay? So this is where you start. So not odd leads to even. Not even leads to odd. Okay, so again, if it's an even number, we just say 2m, where m is a whole number, and then so we have n squared plus 4n plus 1, n squared plus 4n plus 1, so we square n, 4 times n plus 1, multiply out, and we end up with this expression, okay, which is 2 times something, where k equals that 2m plus something, so k is an element of whole numbers, so we've got this 1 left over, so that means when we had n was even, we got an odd number, so we prove, therefore, the contrapositive is true, so therefore the original statement is true. So with these sort of questions in assessment, you'll be told to use contrapositive, okay? You'll be asked to prove it, okay? We've got one more slide. Okay, so this one's a little bit trickier. So we've got x plus y are positive real numbers, and this is the statement we have to prove, okay? So I haven't put the answer in, but it's coming out of the book anyway. So the contrapositive, see? So the opposite of that statement is root x. The opposite of less than is greater than and equal to. Okay, contrapositive, if the second, then x and y and less than becomes greater than. Okay, so we proved, start with the second statement, the opposite of the less than is greater than equal to, the opposite of less than is greater than equal to. Okay, so that's the first part. Now, I'm going to show you two different ways. One's really neat, okay? So I've got root x is greater than root y. So if I multiply by root x, then I've got root x times root x is x. Now the reason I can do this is because I've got positive numbers. So x is positive. So when I multiply by a positive number, I don't change the inequality. Don't change the sign of inequality. If this was negative, then when I multiply through by, well, first of all, you can't square root a negative anyway, but I would have to change the sign. You can't multiply by the square root of a negative number. Okay, so if I multiply by root x, I get x is greater than root xy, and that's the same as just root xy. So root x times root y is root xy. And then I'll change colours. I'm going to multiply this statement by root y. So root x times root y is root xy, similarly, and then root y by root y is y. And so now we've got x is greater than or equal to root xy, and root xy is there, which is greater than or equal to y. So x is greater than root xy is greater than y, so therefore x is greater than or equal to y, which is the statement I want to prove. Therefore, the contrapositive is proved. It's true, so therefore the original statement is true. Now, there's another, I'm going to show you another way. Okay, so we've got root x is greater than or equal to root y, so therefore root x minus root y is greater than or equal to 0. Okay? Okay, so that's just rearranging. Now, because they were positive numbers, because they're positive, I also know that when I add them, because x and y were positive from the original information. So root x minus root y times root x plus root y, a positive number multiplied by a positive number must be a positive number. And then I multiply out the brackets, which is the difference of two squares. So x minus y, so root x minus root y, root x plus root y equals x minus y. And then just ask that to be an equal sign there. And then take the y across, which is what I'm trying to prove. So therefore the contrapositive is true. So therefore the original statement is true. And that's it. So contrapositive, you'll be told that you have to use it. Okay, thanks, bye.